Hi and good day everyone. Welcome to grade 10 science and we're going to have a short discussion about the spherical mirror. So before we begin, let's all start with the anatomy of spherical mirror. First is the center of curvature. It is defined as the center of the sphere in which the mirror forms a section. So this is what we call the center of curvature, or the center in which we dissected a circle. So this is our center of curvature. Start from letter C. And we also have our vertex, or the center of the mirror. So this is our vertex. And the radius of curvature, or the distance between the vertex and the center of curvature. So this is our radius of curvature. Small letter R. A big letter R. So this is our radius of curvature. Focal point or focus, or the point at which reflected rays meet. So in our focal point, this is the center. So our focal point is this one, this one, this one. So this is our focal point. Focal length is the distance from vertex to the focal point of a spherical mirror, half the distance of the radius of curvature of the mirror. So this is our focal point, or focal length rather. And we have our principal axis, or the plane in which the mirror line with. So this is our whole principal axis. So this is the anatomy of the mirror, and they are very important in determining in which or where the image will form and what will be the characteristics of the image. So let's start with the two types of spherical mirror. So we have two types of spherical mirror, namely the concave and the convex. Okay, so this is the structure of our concave mirror. So the reflective surface is inside, while the convex, the reflective surface is outside. There are three important points that we need to understand and we need to check. And of course, not only to check, but of course to know and memorize. We have the center of curvature, the focal point, and the vertex. There are the three important points that we need to understand because they will always appear, particularly in ray diagramming. Let's start with the concave mirror and their special light or light rays. There are two special light rays in concave mirror, or these are the rules in ray diagramming. The first special light ray is that light rays passing through the center of curvature will strike the mirror at right angles and will reflect it back along its path. So if we have here our first light ray, it simply says that when a light ray or a light hit the mirror, it passed through the center of curvature and it is reflected back. So that is our first special light ray. The second special light ray is that the light rays that leave the object parallel to the principal axis of the mirror are reflected and pass through the focus. So if we start here with our reflected rays, so from an object, it will pass through the focal point, but we all know that it will pass through in the focal point because of what we call normal line that was produced here. While normal line was reflected all throughout the center of curvature. And we all know the rules. The rules is the angle of incidence is always equal to the angle of reflection. That's why no matter what happened, this one always reflected back to its surface. And this is the angle of reflection. Same thing that happened when we put that light rays passing through F reflected parallel to the principal axis or axis of the mirror. The same happened when we put it here sa lower part, then we all know that it will pass through the focal point. That's our rule. And at the same time, let's have a counter check on two special light rays. First special light rays is that it hits the center curvature going to the mirror, then reflected back into the center of curvature, CMRC. And our second special light ray is that it hits the mirror going to the focal point, and this is our major rule, MF, CMRC and MF. Center of curvature muna, then it go back to the mirror, then reflected back. On the second special light rays, it hits the mirror from the special or from the object. Going back, the mirror will reflect into the focal point or pass through to the focal point. And these two important light rays are very important for us to understand and comprehend because we will apply it in ray diagram. A ray diagram or mirror ray diagram is a process in which we use two light rays in order for us to identify the location or even the characteristics of image. Are you excited about it? Let's try and let's work with two special light rays. Okay, we have rules. First, we need to draw the light rays. The intersection of the rays determine the image location. For orientation of image, it is formed in the upper plane. The image is upright. If the image is formed at the lower plane, it is inverted. For the type of image, the image is virtual if its formation is outside the mirror reflective surface, but it is real if it's inside the mirror reflective surface. If image is larger in size, then it is considered to be a magnified image. But if the image becomes smaller than the object, then it is considered to be diminished. So let's all try to start. And our first case is if the object is beyond C. If the object is beyond C, let's apply our first special ray. So our first special ray is that it needs to travel into the focal point or center of curvature. So it goes in the center of curvature. So this is our first special light rays. And the second special light ray that we have here is that from the object, it passes through our mirror, then it intersects our focal point. So this is our focal point, and there we have it. And the intersection of the line represent our image. So this is our image location. Okay, so image is a color white rather. So let's start with the location. The location of the image is between the center of curvature and the focal point. So we have between C and F. Well, the orientation of the image, it is formed below the plane or lower plane. Then thereafter, the orientation of the image is inverted. Now, the size of the image is the object is larger than the image and the image becomes smaller. Then thereafter, the image is diminished. And what type of image do we have? The image is formed inside the plane. Then thereafter, the image is considered to be of course, the image is a real image. So if the object is beyond C, we have different characteristics using laws: location, orientation, size of the image, and type of the image. Location is between C and F, orientation is inverted, size is diminished, and type is a real image. Now, if we have here a case number 2, which is an object between F and C, how can we look at it in particular image? Okay, so let's start with our first light rays. So our first slight rules is that, our first rule is should pass the letter C, or the center of curvature. So the mirror will pass, or from the object, it needs to pass the center of curvature. Next, after passing the center of curvature, we have our second rule. So from the object, trace back the image, then forwarded to our focal point. Let me do counter check for this one. Because there are times na medyo kailangan na rin approximate value for it to appear properly. Okay. And this is our image. So let's try to check. The location of our image is that the image is beyond the center of curvature, beyond C. Orientation, of course, it is inverted. Size of the image is, it is magnified. And the type of the image that formed, since it is inside the mirror, this is of course a real image. Okay, that's between F and C. How about if the object is between the vertex and the focal point? Let's try to find out. So we all know that it needs to pass the center of curvature. That's our first rule. And our second rule is that it needs to cover up with our mirror from the object going to the focal point. So this is our second rule. Now, so how did the image form in this invehaft? The image formed outside. Remember that there's a reflective surface of the mirror. So it will go beyond the mirror principal axis. That's why meron tayong tinatawag nating principal axis. And not just only principal axis, but we will determine on what type of image formed outside. Okay. So this is where our image formed. This is our image. Let me give you a solid line for our image. So our image formed outside the mirror, of course, using laws. Location is beyond the vertex. Orientation, of course, the image is upright. And the size of the image is become bigger, so it's magnified. Aside from being magnified, the type of image that form is not real anymore because it is outside the mirror. And the type of image that we have here is what we called, of course, correct, we have a virtual image. Okay, very good. We have beyond V, it's a case between V and the focal point. The object or the orientation rather of the image is upright. The size of the image is magnified, and the type of image that we have is a virtual image. Aside from those characteristics, let's have this one. If the object is in C or in the center of curvature. So the first point is that it reflected back on our mirror, passes through the center of curvature, but this time it will hit the focal point. On the other hand, we need to go with the beyond the F, and it will hit again the mirror. In this case, the image formed, since it is center of curvature and that is the center of the circle, the location, orientation, size, and type of the image. Location is of course at C. This is object at C. But the image also formed at C, or center of curvature. The orientation of the image is, it is inverted. The size of the image is same as the object. And the type of image formed here is, of course, it's a real image. And so that's how we manage on ray diagramming in concave mirror, one type of spherical mirror. Next meeting, we're going to discuss about a convex mirror and their rules. So there are different rules in terms of ray diagramming. Thank you very much and see you next meeting.